Yeah. Okay, it's your time. Hello, everyone. Can you hear me? It's clear?
Yeah.
Okay. It's clear, yeah. Okay, we can start. Yeah. Today's lesson is, for the IoT, this solution. Actually, this is the first lesson about the IoT platform, the basic introduction. Yeah. And after this, we have the two further, the lessons about the solutions and the configurations, and I will introduce some of the project cases, about the IoT. Yeah. But for the first lesson, we just have the review, about this the IoT platform. Yeah. I divided the four aspects. The first is about the IoT solution overview. The second one is the IoT platform. It's the part of our IoT solution, especially for our enterprise project. The IoT platform is the most important. And the third one is the service process introduction about the IoT platforms. The last one is just a simple the case about our networking. So this is first. Actually, as we know, the IoT is the Internet of Things. It can help us to connect the whole the world. Yeah, not only the laptop, but also all the sensors and the cars, cameras, and everything, in our cities and around our lives. So, for example, like the bicycle sharing, especially in China, it's very famous for this one. Yeah, for our IoT, it can help the carrier to locate the location of this bicycle. And the smart healthcare, yeah, for this one, we can also, for remote the suspension and the detection, yeah, and the smart parking. Yeah, and smart household, and especially in China, the very important one is the smart city and the safe city. Yeah, it can help us to connect the lightnings and the traffic rule and the meters and everything. Yeah, so the government can control and monitor all the things. And these three types are the main streams. Yeah, we used, and just different the technical, used for the different scenarios. Yeah, the first is the 45G domain. This is the characters is the bandwidth is very big, more than 10 Mbps, and the high power consumption. Actually, we use this technical, in our smart city, and for camera, especially for the video and the audio services, because the video and audio will request, much higher the bandwidth. Yeah. And the second is eMTC and the GPRS. This two technical has a lower the bandwidth. Yeah, but at the same time, it can support the lower cost and the lower power consumption. For example, for our vehicles, and the electronic the advertising, and some of the about the bank, and for the finance, the service. In this scenario, we use this technical. The last one is the MBIoT. Yeah, this is for the host less minimum the bandwidth. Yeah, and the lowest the cost and the lowest the power consumption. Actually, in theory, it can support for 10 years with his battery. Yeah, without to charge and without to change the batteries. It's for this scenario, we use like the remote meter reading, especially in the place without people and the space very big. If the people to maintain this meter reading, it will cost much because for this will cost a higher resource cost. And this is the most one. Most important, for the whole the structure for our IoT solution. We divide our solution as the 4 levels. Yeah. The first level is the sense level. It consists of all the things, all the devices, the sensors, cameras, and the OBD in our cars and the watches and the other devices, that can be connected to our IoT network. Yeah, this is the first level. And this sense, why we call this sense? Because sense help us collect the information for all the devices. And the second level for network, in this level, we have the many different, the types of the network protocol. Yeah, for wireless one, we have the LTE, NB-IoT, 5G, 4G, and the Wi-Fi, and the other, wireless the protocol. And we also can support the cable in the network. Yeah, we have the IoT gateways can support to connect our cable network. And this network is, we also call it the access level. Yeah, it can provide the network to help us to access the devices. The up level is platform. Yeah, this is our IoT platform. Yeah, Huawei will provide this part. And this part can connect the sensors and the cameras over the network. Yeah, and we call it as the southbound. Yeah, the interface connects the devices, and it can also provide the northern branch, the northern interface to access the applications, different applications about the vehicle, services, and the smart home services, and the safe city, smart city, and the remote meter reading, yeah, and so on, And on the one hand, it connects the devices, and the devices will send all the information to our platforms, and our platforms will store it, process it, and maybe the encoding and decode, yeah, and can manage all the devices, the status, and monitor their information, and can help with the batch, the upgrading, and the batch configuration. Yeah, it will provide a unified interface for all the devices access. Yeah, and the last level is for the application. Yeah, this is is provided by our partners. Yeah, it's for the service. Just now I have listed that for the smart city, safe city, and the remote meter reading, and so on. They will provide the servers and provide the detailed services, and they will connect our platforms, and will send the comment and send the information, and to help to control the devices. Yeah, this is the whole architecture, for our IoT. And this is our Huawei, the 1+2+1, the IoT architecture. And for LoRa, we have the Huawei, the Light OS. Yeah, this is the OS system, and with module. And the middle is that the network, yeah, wireless network, and the fixed network. The last is for IoT platform. Yeah, actually, in for enterprise solution, we just pay more attention on IoT platform, because all we need to do config, to connect is finished on the IoT platform. Because for the network and for the devices, yeah, it's different in different projects. But the IoT platform is all use only one the platform. So the IoT platform is the most important. Yeah, and next is for edge packaging for our platform. Yeah, this is the challenge when we in the true life. The first is that actually for our smart city or safe city, yeah, we need many different services that to support our running. Yeah, for example, the telephone system, the map system, G system, and the email, and the CCTV video, and the video conference, and the other different services. But this services is many different kinds, and we need to create the different servers and the different the maintenance guy, to maintain them and to configure them. It's very complex and inconvenient for us. Yeah, and the second is that in our city we have many different sensors and devices, like the garbage and the light and the vehicles and some others. So if we want to manage all of these devices, it will be very difficult for us. And the last is for the network scenarios. In our city, we have many different kinds of the networks: wireless, Wi-Fi, and 4G, and Bluetooth, and for our cable network, and many so on. Yeah, so different network connect different devices. So different devices, connect out the platform, by the different network. It will make this difficult technical. Yeah. So when for these three challenges, we need to provide unified the platform. This platform can help us to access all kinds of the devices. Yeah, and it can help us to connect over all kinds of networks. It also can help us to connect and provide the interface, provide a service for different kinds of the applications. Yeah, the platform can help us to make all difference, in the same standard. Yeah, this is the function of our platforms. Yeah, here we can see we have the three aspects, for his capability. The first is for terminal access discovery. Yeah, this one, it can help us to access all kinds of the devices, because our platform, can support many different protocols. Yeah, different protocols, access different devices, but our platform can support all of them, or most of them. Yeah. And the next is for capability open up. This one can help us to access different kinds of the applications, different services. Yeah, regardless of the vehicles and the metering and the light and so on. Our will provide a unified the interface and to connect them. And the last is for the secure and reliable. Our platform, when we connect the device and connect to the application, we provide the authentication. Yeah. And this method will help us to make our connection more security. Yeah, as we can see, this is the simple the architecture for the IoT platform here, the cloud here. And our IoT platform to divide the different functions, yeah, in different modules. We can check two levels here. First level is for the service enabling. Yeah, this one is to help us to support different services. The first one is for open APIs. This service process can help us to access different kinds of applications, like the smart code, the IOV, and the smart meter reading, smart city, and others. Yeah, we need the open APIs to connect them. Another one is service orchestration. This one to help us to make the data, to management, because different the services, it has his own the private messenger information, the format, and his own standard. Yeah, this one help us to make all these different standard, different formats, make in the same standard, same and the same format. Yeah. And next, the rule engines. It is a event action. For example, if we collect the light, yeah, the light is light on. If light on, is this event happened, and we can define the action. Yeah, we have the to occur alarm. So when this the light on, and it will send a alarm message to this system. This is the event to action. And another example for that, we can create the rule engine based on our time. For example, if we want to get up at 7 a.m., yeah, we can create the rule that when 7 is up and it's raining, we can set a raining the alarm. Yeah. And the next is the big data analysis. This is easy to understand because our platform can connect many different kinds of devices. It will provide many very big data. Yeah. So this is a big data analysis service can help us to solve or process to make us to improve understanding for these data. And the second level is for the activity management. This is for the connection, the management, connect our app, connect our services, connect our devices. Yeah, it's for this management. First one is the SIM card. For example, for our IOV, we have the OBD onboard that one to install it on our car. Yeah, and this OBD can connect many informations like the speed, yeah, like the time, and like the oil, yeah, many informations. And but another thing is that in our CBD is embedded SIM card, just like our mobile phone. Yeah, our mobile phone can connect the network by this SIM card. Same time, this the OBD can connect network by this SIM card. And the next is equipment management. It's easy to understand. Equipment like the sensors, cameras, and meter and others. Our IoT platforms can make a list or can make divide different group. Yeah, based on these devices. So we can to check the status and monitor these devices on IoT platforms. Another is the connectivity management. This is for communication between our platforms and the devices. Because, for example, for our car, we have many information of our car speed and the temperature and the oil and others, but not actually for the career. Not all these parameters we need. We just want to know 3 or 1 of them. For example, I just want to know the speed for this car, not other parameters. At this time, we need order it, to send a message from the IoT platform and to this device, and then this device can only send this speed message to the platform, not other parameters. This for the connectivity management. And the next is for security and authentication. Just now I told you guys about our device access and our application access. We provided this authentication. For example, for our device, we provided the device ID, and the encode number, and a PS key, a key. So if a device want to register on our platform, it must send this information, device ID, his device ID, and the encode, and his PSK key, or it cannot register on our platforms. The last is the operation management. For this one, our IoT platforms can provide three types of portals, web portals, for different users. For this type, later I will show you, which kind of the web portals. This is the hosting architecture for our IoT platforms. Totally, it's divided in 5 levels. And sometimes it's maybe the same as the IoT solution, but it seems some different. You can check that. The first is terminal layer. It's the same, and same like the 6 terminals because it is the same. The next is access layer. It's still like the network layer for different networks. The difference is that here, the connection layer and the enable layer here. This is just the platform. But here in this situation, we divided the two. The one is connection layer, another is enable layer. Just I have the instruction for connect. Connection is connect the devices, connect our applications. It will support the devices management and the protocol management and the security and the authentication. And the neighbor layer, can support the APIs and the rule engine and the data management. The last is application layer is the same. It can provide different the services. And the later is the detailed introduction. We will check here. Actually, for enterprise project, the most scenarios is the city, not smartphone. Smartphone is always used for the career side. For our enterprise side, we use the IoV for the Internet of Vehicles. And another is smart city and safe city. These 3 scenarios is the most the situation. And it's enable layer. It's just I told you it can support the APP and API project management to provide the open API to connect all the applications. And next is the data management. This one can help us to make all the different types of data in the same standard, and and the same format. So this can be understood by this platform. And this is the rule engine. Rule engine, it is the event to action. And next is for connection layer. Okay, here. This is for device management, for all the sensors and for the cameras. And next for the communication management. It's for that communication between the platforms and the devices. Here you can support different the protocol like the MQTT and COPE and J808. Yeah, the different protocol be used in different scenarios. And next is the lightweight authentication. This was security. Yeah. And next is the access layer. It introduces the three types the network. Yeah. But actually, for example, in the IOV, it's the internet of vehicles. We always use the 3G or 4G because the OBD installed on our cars embedded a SIM card. Yeah, so just based on the 4G network and 3G network. Yeah, we use this one. And actually same as Smart City. But actually, some scenarios, for example, we use the remote meter reading and the light, yeah, light will connect and garbage connect. Yeah, this actually, we need cost less consumption because if the cost much consumption, the battery, cannot support too much time. And so in this scenario, we always use the MBIoT this protocol because this protocol is cost much less the consumption. Yeah. So we don't need change the battery all the time. Maybe for several years. Yeah, we just change it one time, not every month. And this is terminal layer just intelligent for different kinds of terminals. Yeah. Uh, for intelligent terminals, like the smartphones, computers. Actually, in some countries, they always support the smart home, and it can connect all the devices in our home, and we can control our devices in our home by remote, or we can to configure the rule engine, yeah, and do other some automatic, the configuration, and this help us our home be intelligent. And the sensor, yeah, sensor just like a camera, yeah, and for like the cars, OBD, the same like this. And next is some service and functions detailed for our IoT platform. We can check the first one. The first for device management, we can check. Uh, we have the gateway. This gateway is connected to the devices because actually some devices cannot connect our IoT platform directly. We need to provide a gateway yet to as an agent and connect our platform. And this is a directly connected devices. Yeah, and they all connect to our DM server. This is um, a, 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 a service of our IoT platform. And this is the FP portal. FP portal for different careers, and they will, to make some configuration and to send the command, to send the message, and by this FP portal, and then this message can be sent to our DM server. Yeah. For example, just make some configuration. Yeah. To make the upgrading. Yeah. And then our DM server will send this comment and a message to the gateway. Uh, the gateway will transfer to the devices, or it will transfer to the directly connect devices. This is the device management. Yeah. And this is the device communication management. For example, for our gateway logging, yeah, because some devices cannot connect our platform directly. It will use the gateway as an agent. So the gateway must register on our platform before the device registered. And the next is the data communication. It's just like the because the gateway and the platforms and between the platforms and devices, yeah, we will need some protocol, for communication. Yeah. So we can support many kinds of the protocols, like the MQTT. Yeah. And this tool, the user initiated subscription and the device initiated subscription. It means that uh, the IoT platform can order the parameters of the device, and the device can also can order some the parameters from the IoT platform. So we don't need all the parameters. We don't need all the information. We just to select some of them. Yeah, this is called initiated subscription. And the next is for device access authentication, which we divided the three the levels. First is for the authentication during the sensor creation. For example, um, before the sensor registered on our IoT platforms, we need create account for its sensor. Yeah, just like the phone number, when we register this phone number, we need to create a phone number on our gateway. And then this IP phone can register with this phone number, the same. So when we create this sensor, it will automatically generate some the ID or the secret, yeah, for the authentication. And the next is for data reporting authentication. For example, when the sensor reports data, the gateway carries the valid sensing information allocated by the IoT platforms. Yeah, and the IoT platforms will verify this information. If not, if it is invalid, it cannot be transferred. It will be forbidden. And lastly is the device access authentication. Yeah, this one just now I have the brief introduction. For example, when a device register, it must provide his device ID and his inode number and his PSK. This is a key. Yeah, and he will send all the information to the IoT platform, and the IoT platform will verify this information. Yeah. And next is rule engine. It have the for example triggering condition. The three different types of trigger condition can support. First is find based on the time. Yeah. And the next is for data report. Just have the message. For example, if the like just temperature up to the 25, yeah, it's a normal one, but it up to the 30, yeah, it's very high. So this time we can to generate a alarm. Yeah, this is for the data. And the last is for the event. Yeah, just like the if the mobile or the camera, if it send a alarm to us, yeah, we get alarm from the camera. It will generate another alarm. Yeah, this is based on the device the action, and this is the response action here. And this is the API. It means that for the open API management, because just now I have introduced that our IoT platform can support to access different kinds of the services. Yeah. And this is detailed the function. First is for app management, because our platform can support to connect the services, and we call this service as network applications. So the network applications just with services, and when we connect it, we need authentication. Yeah. And next is for device resources management. This is the same. I have introduced for that. Just can to divide our device in different group for the much easier management, and we can also monitor all the status of these devices. Especially, we can support the JIT system. We can connect the online map like the Google, yeah, and we can also to support the offline the map. Yeah, we can create our own map service, and then we can do some configuration about the location information for these devices, and this device will be displayed on the map system. And the next is for device management. That's the same like that for the batch configuration and the software upgrading. Yeah. And this is the forwarding agent. Just I told you that some devices cannot connect our IoT platforms. It must use the agent gateway as an agent. And that's the rule. This is the rule. This is the rule engine to event to the action. That's a subscription notification. Yeah, this means that for every event that the device generated, our IoT platform supported to generate alarms, generate a notification to the our services. So this service server can monitor all the action of the device. And this is the multi-tenant management. We can check that it's in different level. The first level is device. Yeah, different device. And next is the code. This means that different the hardware, the server, the HP, Dell, Huawei, IBM, different servers. And the next is platform. Yeah, this all the platforms running in this different types of servers. It can also, support the cloud deployment. And over this platform, yeah, we can create the app. This app means that the different services like smart home and wearable smart city. Yeah, this is the app. This is a physical isolation, and this is the virtual isolation, and the logical one. Yeah, the first situation we can check, the one IoT platform can only support one app. Yeah, and the next virtual isolation is still, can only support the one app, but this platform running in the virtual cloud, virtual resources, not in the physical resources. Yeah, this is the first one, and the second one was difference. But the last one is our platform. It means that it cannot only to running in the virtual level. Yeah, and it can also only one IoT platform can support many kinds of the app. Yeah. And the last this one is port management. Just now I said that our IoT platform provide three types the portals for management. The first one is called the OSS portal. This one is for the installation for IoT platform installation configuration. Yeah, for his basic like the time, like the network routing, and like the IP, and like the service. Yeah, it has some sub web portal. The first one for the service plan. Second one is for the managed plan. Managed plan just like monitoring. Yeah, for this portal, we can monitor all the services of our platforms. Yeah, it's for maintenance, and then we can check the status for our platform. And the service plan is for the configuration. Yeah, for example, for the IP configuration, for the access interface configuration, for the routing configuration, and for the date and for the time. Yeah, we use this service plan. Managed for the monitoring, service for the configuration and installation. Yeah, and the next one is for the operation portal. This is one is for the career. Yeah, for the career of the IoT platform. It means that, for example, for the vehicle, the vehicle, the company. Yeah, if we create a IoT platform for it, and the vehicle company will be this career, and they will use the operation portal. In this portal, we can do some common configurations for our IoT platforms. For example, for map, we can configure the which kind of map, online map and the offline map, and we can also to create the users. Yeah, just now here, because we can support multi-tenant management. Yeah, different tenant use a different account, so we can create this account on this operation portal. Yeah, and then this is the SP portal. This is SP portal used by the tenant. Yeah, one tenant, one account, and they use this account to log in SP portal, and then they can to create their application. For example, create a vehicle the application, and to create a watch. Yeah, the watch, and they can monitor the watch status and the running speed and the health status and others for watch. And we can also create a camera CCTV system, the application. Yeah, we create all the application on SP portal, and then it can also help us to have the reported statistics. Yeah, all the devices and all the status, all the messages will be displayed on this SP portal. So we can monitor all the information about the devices here. And then we need also to connect our device and connect the application server, the service server. Yeah. So we did this, finish this on SP portal. We need to do some configuration. For example, for later I will show you that details. Yeah, next is for IoT platform service, the process, the detailed about how the IoT platform work. Yeah, this is the simple, the architecture for the IoT, our IoT solution. We can check the lowest is the IoT devices, like our gateway devices, the sensor, the cameras. Yeah, and they different kinds of the devices use different the protocols. HTTPS, JT808, MQTT, COPE. For example, for the IoT, for the for the internet of the vehicles, we always use the JT808 this protocol. And the blue one is our the platform. Yeah, we have the permanent access protocol adaptation. This one can support different kinds of the protocols and access different kinds of the devices. Yeah, and the next is for the IoT application service. Here, it also is for our the IoT platforms. This too. Um, this tool is all this can do. belongs to our IoT platform. Yeah, the lower one is for the access device access. The upper one is for the application access. Yeah, and the last one is for application client browser, like this here. And then we can check our Ocean Connect can also support our different third-party services like the SMS, the gateway, the email server, and of course, and also can support the weather, the map, the position, and others. Yeah. So this is the basic. And next is for the some key product we use in our solution. First is the MQTT. This is for the full name is the message querying and telemetry transport. It's always used by the how do you say that? By the sensors. For example, cameras. Yeah, they use this protocol to connect our IoT platforms. Yeah. And next is for COAP, COAP. Its full name is the Constraint Application Protocol. Yeah. It always used in NB-IoT, this network. Yeah, because the NB-IoT can support very less bandwidth and cost less the consumption. And so this protocol can also support these features, low consumption, yeah, and less the bandwidth. And then next is for all the main process and services on our IoT platforms. Yeah, we can have the check. First is for the application server registration. Registration include two: registration and authentication here, and the device registration for device registration and modification, e-registration, and the device registration information reporting. We have the report and the authentication. Yeah, for example, report is after authentication we have the temperature and it's the messages and the other parameters and humidity reporting, electricity meter, yeah, and other parameters here. And next is for device management and control. For example, for the device configurations and the information storage, upgrade, remote control, and others. Yeah, for the big data, for the artist yeah. And next is for the road for our yeah, this is our IoT platform. Include many types of the process, different process or different functions. The lower is for the device. Yeah, it's the device. This one, we call it the LB. Load balance. Have the balance service. It can help us to access different and this one is for the application server. Yeah, we also have the API server. This one can also help us connect to the other and the left is three types of the porters. Yeah, it can also connect. And next is for the northbound registration process. Hello? Hello? Hello?
Hello. Hello.
Hello. Yeah, I can see. I can hear.
Yeah, Shoaib, can you please tell Shoaib to mic? His mic was open. I think he is closed now. You can continue, sir.
Closed.
Shoaib had his mic open. Okay, he has
Yeah.
just muted it. So thank you. You can continue, sir.
Okay. Okay. No worry. Okay.
Yeah.
This process, when we do register on our application on our platforms. Yeah. First of all, actually before this, yeah, before we log in the SP portal, we need to create create account on operation portal. Yeah, operation portal, operation portal. And after we create the account and we use the account to log in the SP portal, and then we can create application. Yeah, this application, not the real this application server. It's just like the authentication information. It includes uh, associated API package. It means that different service needed a different API package. Yeah. For example, for the IOV, it must include the IOV package. Yeah. And then after we create the application, it will generate the application ID and the password and the access address and the port. This includes uh, the access for two types. First is for the application access the address and his port. Another is for the device access the address and the port. So after we create this application, we can connect to this IoT platform, use this application address port and device address and port. Yeah. And then we need to upload the device profile. This is a profile, it's just a description of this device. For example, like the water meter. Yeah, it will include the device type, it's water meter, and his manufacturer, which render, and the device module, and his device capability. Yeah, it can also, have some the format for his comment and his format for his data. Yeah, this profile provided by the render manufacturer. Only we upload this profile can the IoT platform can recognize and can decode, yeah, this message from the device. Or our IoT platform cannot recognize the message. And after that, we need to upload the device codec plugins. This one for code, for message code and decode, because the different device, maybe has his own encryption, the method or protocol. Yeah. So we need to upload the relevant the codec plugins in our IoT platform. So our IoT platform can decode and decode this message. And our decode, this format, and we have the standard the development guide, and the partner will develop this the codec based on our the standard the guidebook. The last is for the interconnect our the platform and applications. Yeah, you just use the app address and port and the app ID and the password. We will do some configuration on the application side and our SP portal, and then the application can connect our the IoT platform. Yeah, this is the whole process, for the application registration. And this is an example for how different, the manufacturers, to work in our IoT platforms. We can check here. The green and water platform. Yeah, maybe for the customer. Yeah, customer has a platform. And the blue one for our platform. The red one is provided by the yeah. Maybe this it has hits the meter with many different types. Yeah, it has different types of water meter, but with one application. So the red is provided by the type. The yellow is provided by water meter type 2. Yes, water meter type 1 and water meter 2 is provided by different manufacturers. So we can check that. Water meter 1, yeah, to connect to our two protocol stack. Water meter always use the full protocol. So it will connect our full protocol stack on our platform. And then our platform will up linking the message to process codec here. Codec. The yellow is wrong. The one is red. The codec here. Because just now we upload the device codec plugins. So it will help us to codec the meter 1. Because our meter 1 here have many parameters like this water meter, daily activity time, internal temperature, flow, and reverse flow. Many parameters for this parameter, for this water meter. It be decoded, and then our IoT platform can recognize it. And after it's code, it will send to the water application platform. Yeah. And then we can check when we decode, we need the profile. This profile, as I told you, is a profile description for this device. Yeah. We decode this message based on the profile. Yeah. And the same situation for the water meter 2. We need also to upload the codec plugins for this water meter 2, and then our platform can recognize this one. This is the uplink message from the water meter to the water application platform. If the water application send the message or send the comment to the water meter, it will send the message with this format, and our codec will encode this message in its relevant or the macro format of the water meter, water meter 1's manufacturer. Because water meter 1, the manufacturer has its own format. So this codec plugin will encode it to his own format and send the message to the water meter 1. Yeah. So this is the process how the codec will work, for code and for decode here. And the profile, can help us to describe this message. And last is just basic case. Yeah, for the chain-based internet or vehicle network. I'm delivering a project for this chain-way now. Yeah, we use this network. This is our IoT platforms, and this is devices OBD, the onboard discussion. Yeah, the installed on the car. So on the car, it can help us connect to all the information for the car, and then our platform connect to the chain-way fleet management application. Yeah, and then the OBD will connect to the class information and send to our IoT platform, and our platform will send to the fleet management system. Yeah. Yeah. And we can check we have the SMS message. Our platform can also support the connect SMS. For example, like the rule engine. Yeah, if the very urgent alarm from the OBD we received, we can send a SMS message to his owner, to this car owner. Yeah, like a rule engine. This can help us to complete this function. And the next is for maintenance, for the SP porter, and then for operation porter, and for OSS porter. Yeah, this can help us to maintain and configuration of the platform. This is for Chen Wei. Chen Wei can support the two kinds. He has his own web portal, to manage his fleet management system. For the web portal and the mobile app, yeah, it can also connect to the content provider like the map, like the weather, and it can own connect to the SMS and email. Yeah, and this is the metrics and the responsibilities, the metrics for the Chen Wei, fleet management system delivery. Yeah. For this situation, we can check this side is all for the Huawei side. For example, for the hardware layer, yeah. This is the network plan, yeah. It's network plan here, and the network layer, and for the virtualization software layer, yeah. It's all belong to the Huawei side, and the IoT platform side is also our. The Tianwei, they can only support his own systems. Yeah, and we connect to each other. And the last is for the service rollout commissioning. Yeah, for both. And this is for the delivery process for our IoT platforms. We can IoT platforms, so we can divide it. The first step is for this is for the prepare, like the obtaining the plan data, yeah, and hardware, and the virtual layer, and application layer, some informations about all. After that, we can to create the start the delivery. Yeah, this is for infrastructure layer. For virtualization, fusion compute, and fusion manager. Yeah, we need this for virtualization. Yeah, our IoT platform running on this virtual layer. So we need to create the virtual layer first. Yeah, it has two layers. Hardware layer include our servers IH2288H or the other kinds of the servers. And then it's virtualization software layer. Yeah, we can also support to the web portal for management and to config. And then we need to create the virtual machine on this infrastructure layer, and all this IoT platform we're running on this virtual machine. So here is for the virtual layers. We can deploy the IoT platforms one by one. Firstly, for the platform application software layer, and then for the application software layer. Yeah, this is the this green one is for the cloud area. Yeah, in our project, when we have the cloud, yeah, all the services running on this cloud. We actually for this situation, we don't need to install the servers. Yeah, we just only to request or apply the ARS resources. Okay, but if not the cloud, yeah, we need to hardware installation and power on and cabling. Yeah, we do this, and then we need to do the data planning installation preparation, like the read and like the network and like the software, yeah. And then install the Fusion Computer and Fusion Manager. And then we configure the FM to create the virtual machine. Yeah, to store the OS platform on the virtual machine. And then we can install our IoT platform. After that, we need to configure our IoT platform. Yeah, basics and like to create the SP the users and the create application and connect the application and the test the services. Yeah, this is for the a simple introduction for the IoT platform delivery process. And this is all for the practical introduction for our IoT solution. The most important for the IoT platforms, yeah, we have the detailed for like the platforms, and the IoT platforms can support the both sides. The southbound to connect to the devices, the northbound to connect to the applications. We can check that. So this is the practical introduction for the IoT platform. Anyone have some questions about this? Hello?
Hello.
Hello, any questions?
Hello.
Hello?
Hello. Can you hear me?
Yeah, I can.
So I have only one question.
Yeah.
In the last delivery process, okay.
Okay, here, yeah.
Yeah. So this IaaS resource application.
Yeah.
How can we put this? You are talking about some other vendors like AWS or another vendors which are providing IoT solutions. So you can um, migrate their data hosted on that into this platform, right? Is it that you are talking or is it something else?
Actually, for this one, this is only for the cloud side. For these details, about the which information, yeah, which parameters we need, it must be based on the different clouds. For them, yeah, different. For example, yeah, we have the project PSA, in France. Yeah, we have this project, and we use the Huawei cloud. Yeah, but actually, this cloud is very complex. If we want to apply this the information, where the basic information, the resources like the CPU, yeah, memories, and the servers, yeah, like this. But actually, it may support the much more complex parameters for that.
Okay. Yeah, I had only one doubt regarding that.
Yeah, and actually, when we apply these resources, we need to consider the extension. Yeah.
Okay.
Okay. Any questions?
Thank you very much.
No worry.
It was good.
No worry. Anyone has any questions?
I think no, they are not here.
Okay. Later I will share this document, and any question we can to chat on Space or other places. This is just for the basic information. Later we have the further study about the delivery. It's for the detailed the project. That will help us to further understanding for the IoT. Yeah. Okay.
Thank you.
Okay,
Yeah,
thank you,
thank you.
guy. Okay. See you.
Yeah.
Bye.
Yeah. Bye.